In this lesson, we're going to learn how to graph quadratic relations using key features that we can find in standard form and factored form. So let's recap from our last lesson. Standard form is y equals ax squared plus bx plus c, and the a value, the coefficient or number in front of x squared, gives us the direction of opening. So does our parabola open up or down? And the c, the constant, or just the number at the end, that tells us the y-intercept. So when does the parabola cross the y-axis? So those are the key features of the parabola that we can determine from standard form. Factored form, our equation is y equals a times x minus r times x minus s. And that a value, again, we have the exact same letter as standard form, and that is because as we switch between the two forms, that number is going to be the same. And so it gives us the same piece of information, the direction of opening. The r and the s values, those tell us the zeros or the x-intercepts. So same name. Different names for the same thing. When does that parabola cross the x-axis? So, how can we graph using key features of quadratic relations? You're going to be given 2 pieces of information, and then you're going to need to determine 5 pieces of information from that. So you'll be given the vertex, and then you will be either given standard or factored form of the quadratic relation. And we've just talked about what pieces of information you get from standard form and what pieces of information you get from factored form. So you're going to need the axis of symmetry. You're going to need the direction of opening. So this you get from both forms. You're going to need the y-intercept. So that you need standard form. The zeros or x-intercepts, for that you need factored form, and a symmetrical point to the y-intercept. So for that you need to know the y-intercept and then also the axis of symmetry. The axis of symmetry is just the equation of an imaginary line that runs through the vertex vertical line, and it has an equation of x equals. And the x will be whatever the x value of the vertex is. So from that, we will see in a moment that we can determine how far the y-intercept is from there, and the symmetrical point will be the same distance on the opposite side of the axis of symmetry. So whether we're given standard or factored form, we're going to need both forms of the equation. And in our last unit, we learned how to work from one form to another algebraically. So either we will need to use binomial expansion or quadratic trinomial factoring. So let's take a look at a few examples here. So what are we given? We have the vertex. The vertex is at -2, -1. And we're given standard form, y equals x squared plus 4x plus 3. So standard form gives us an a. In this case, we have no number written in front of the x squared. So that means it's a +1. And a positive a value tells us that our parabola opens up. From our vertex, the x value is the same as what our axis of symmetry is equal to, so x equals -2. So we can go ahead and plot our vertex at x is -2 and y is -1. And then we can also put in our axis of symmetry at x equals -2. So other pieces of information that I can get from standard form are the c, which is a +3 here, and that is my y-intercept. So my y-intercept is when I touch the y-axis. So that is going to be at +3, so that is over here. So at that point, my x value is 0, and my y value is 3. Now this is a new thing for us, so the opposite of the y-intercept. So over here, I have my axis of symmetry that I've drawn in, and the y-intercept is 2 points away from the axis of symmetry. So if I move another 2 points, I'm going to have another point at that exact same y value, so a y value of 3. So this is -4, 3. This is the point that is symmetrical to the y-axis, or sorry, the y-intercept. So that is at -4, 3. So that's this point over here. So the last thing I need are my zeros, and that I can determine by doing quadratic trinomial factoring. So I need to take my equation and figure out what are the two binomials that multiply to that. So I know that x times x multiplies to x squared. Now I need to figure out which two numbers will multiply to a +3 and add to a +4. Now because both of these are positive, to multiply to a positive number, I need either 2 positives or 2 negatives. And because b is positive, it's going to be 2 positives. Now the only numbers that multiply to 3 are 1 and 3, and 1 plus 3 equals 4. So those are the two numbers. So there is our trinomial factored into two binomials. And that now helps us find our zeros. So remember, for our zeros, the bracket needs to equal 0. So something plus 1 is equal to 0. That happens when x is equal to -1. Or when x is equal to, so x plus 3 is 0, and that happens when x is -3. So -3 plus 3 is equal to 0. So -3 and 0 is our other 0. So we can go ahead and plot those. So I have -1, 0 and -4, 0. So I'll take a quick look here. I have my vertex. I have my axis of symmetry. I have both zeros. I have the y-intercept, and I have the point that is opposite to the y-intercept. So now I have enough points to be able to plot my parabola. And then I'm just going to draw in that curve. And there is the parabola for the quadratic relation y equals x squared plus 4x plus 3. So let's take a look at an example where we start in factored form and then need to move to standard form. So I'm given my vertex again. I have 1, 4 is where the vertex is. I have an a value of -1. Negative means that we open down. So my direction of opening is down. My axis of symmetry is x equals, and because it goes through my vertex is at x equals 1. My axis of symmetry is going to be at x equals 1. So I have my axis of symmetry, I have my vertex. Now from factored form I can figure out zeros, so what -3 is equal to 0? 3 minus 3, so that happens when x is 3, y is 0. And the other one is a +1, so something plus 1 is equal to 0. That happens when x is -1. So -1 plus 1 is 0. So those are my two zeros at -1, 0 and 3, 0. So I now have my zeros, and to get my y-intercept, I now need to go ahead and do my binomial expansion. And because I have a -1 out in front here, I'm going to keep that outside, and then I'm going to put my resulting trinomial inside of set of brackets. So here I have x times x, that's x squared. Then I have x times 1, which is positive 1x. Negative 3 times x is negative 3x, and negative 3 times positive 1 is negative 3. I'm going to now collect my like terms. So I have x squared minus 2x minus 3. And then I'm going to multiply my negative 1 through. So negative 1 times x squared is negative x squared. A negative 1 times negative 2x is a positive 2x. And a negative 1 times a negative 3 is a positive 3. So now I have some more pieces of information. My a I already knew was negative, so this opens down. The other piece of information I get from here is my y-intercept. So that happens when y is 3. So when x is 0, y is 3. So I can plot that over here. And then the symmetrical point, so this is 1 away from the axis of symmetry, so I'm going to move 1 over on the other side. And so that's going to be at x is 2, y is 3. So there's my symmetrical point. So I now have plotted my opposite to the y-intercept as well as my y-intercept. So the last thing I have left to do is to draw in the parabola. And there we go. So that is how we can plot a quadratic relation without substituting in x values to create a table of values, but by using the key features that we can get from standard and factored forms, and using the algebra skills we learned in our last unit to go in between those two forms, or to go from one form to another.